Welcome back. Happy Friday. Today is the 20th. Today we're going to do things a little bit differently in that we're going to try to tackle a little bit more than one lesson today, and the same for Monday, because the snow day has kind of crunched our calendar a little bit, and I've handed out an updated calendar. It looks exactly like what's projected here, but what you don't see is what I took out. And what I took out was a review day right before quest number 2. And I'm wondering if maybe there's a way for us to kind of squish a little bit in these next few classes and then have part of a review day before quest number 2. So I've written over here on the whiteboard our tentative calendar. So today we're going to cover class 7. That was the plan as usual. But we're also going to try to tackle the demo for class number 8. I don't know how long we'll have after that demo is done. We'll see. The plan for Monday is to finish class 8 and tackle the demo for class 9 and maybe even get into the activities for class 9. Class 9 is the last class before the quest. I'm hoping that we have a bunch of time on Wednesday after you finish the class 9 activities to just really review for the quest, which is coming up a week from today. All right, so quest number 2 is next Friday, exactly. And you can see from the calendar that the quest covers classes 6 through 9. So today is 7, so we still have 8 and 9, and then 6 was right before the last quest. So I've graded about half of the quests. I don't have them to give back to you, but I'll hand them back on Monday. Okay. Any questions on the calendar? Yes? So I don't, the way that I grade them is a page at a time, and so I can't say whether anybody has done well because I haven't finished grading anybody's individual quest. Yeah. Yes, Alex. Anybody else having any? How do you find that? It just says alternate login? Okay. Right. So we can figure it out individually, but maybe right after class we can pull it up and just see if we can find this alternate login link that Kayla's talking about. Okay. All right. Other questions? Okay. So again, we're on page 48. So let's jump in here at the top of page 48. And we'll start with Tyler, summary. Thank you. Number 0 here is this important note that it's exactly the same as the note from last class. It talks about this word function, which you will see in some of the upcoming homework, which we are not going to cover, but that you will just replace with the word equation. And you're going to see crazy looking symbols like F parentheses, X parentheses, and you're just going to replace them with a Y. So this is just a reminder that in the coming homeworks, you're going to see stuff that we have not covered, and you're just going to know, okay, I got to go back and check out the note to exactly know what I'm supposed to replace, okay? So it's just a translation thing. All right, moving on to number 1. It says, consider these 3 points, 7, 2, -4, 2, and 0, 2. Go ahead and plot all 3 points right now on that grid. Okay, 3 points are plotted, yes. Part B says, what word, are we still plotting? All right, good. So part B says, what word describes the line connecting these points? It's horizontal, right? There's a straight line, and it happens to be horizontal. Part C says write an equation for the line that passes through these points. Okay, so taking a look at the coordinates of those 3 points, what is consistent in all 3 points? The 2. And the 2 is in which spot? It's in the Y spot, yeah? So we would all agree that Y equals 2 accurately describes the similarity between those 3 points. And Y equals 2 is the answer to this problem. Y equals 2 describes every one of the points on this horizontal line. Every one of the points on that red line is something, comma, 2. Agree? And that equation looks kind of funny because we're used to seeing from last class y equals mx plus b, right? And that doesn't look like y equals mx plus b. Okay, so I'm here to tell you that horizontal lines, which we just talked about, and vertical, which we're about to do, they don't all have the form y equals mx plus b. So they're just kind of like two special things, and that's part of what we're after today, is like how do we handle these special ones, the vertical and horizontal. Okay, and part D says calculate the slope. Okay, so this is good practice for our slope formula. So remember, yeah, Lucas. Okay, so Lucas is saying m equals 0. Are you saying because of the way the equations compare to each other?
No, just that also adds the fact that there's no slope.
It is a flat line. All right, so he's right. Let's see if we can verify that 0 is the slope. So we'll pick any 2 points. How about these two right here? I know that the slope is a change over change. What letter goes on top? Is the y. So we're going to subtract the y's upstairs. So how about we do this direction 2 minus 2 divided by, and then downstairs, what do I have to do? -4 minus 7. It's okay if you did 7 minus -4, as long as you're consistent with your order. Upstairs, we get 0. Downstairs, it hardly matters. It's -11. It's a fraction. How much is 0 divided by -11? It's 0. And so Lucas is right. The slope of this line is 0. And it kind of makes sense, right? Because typically, when you're on like this kind of a diagonal line, the slope is like how much do you have to rise and then how much do you have to run? Yeah? So if we try to do that on this line, how much do we rise? Nothing. And you can run as far as you want, but you're not going to rise anything at all. And so if you rise 0, then your slope is 0. Okay, that's good there. All right, next part of this is number 2. Consider these 3 points, 4, 2, 4, 5, 4, -3. We're going to do the same thing we did up above, so begin by plotting those 3 points. All right, so we've got our 3 points plotted. And what word describes the line connecting those points? It's vertical. And the next part says write an equation of the line connecting those 3 points. So just like before, we look at all those coordinates and we ask ourselves, what's the same? It's the 4. And where is that 4? It's in the x. So would you agree that x equals 4 describes the similarity between all those points? And so that's the equation of that vertical line. So I'll draw it in another color over here. But every point on this vertical line satisfies x equals 4. And so that's the equation of that line. Again, it doesn't look like y equals mx plus b. The horizontal and vertical lines are different. They're special. They only have one letter in them. Normally, y equals mx plus b has a y and an x. Every diagonal line you think of has a y and an x in its equation, but the horizontal and vertical are these two special cases where they just have a single letter, not both. Okay, calculate the slope here. Let's give it a shot. How about we use these first 2 points right here? Again, we know that the slope is the change in y over change in x. I'll go that direction, so 5 minus 2 upstairs. Downstairs, 4 minus 4. So on top we get 3, bottom we get 0. What is 3 divided by 0? 0? Can't do that. You're going to tell me what I can and can't do? What is it? Undefined. Yeah, we know we're not allowed to divide by 0, right? You've been taught from a very young age. You divide by 0 and the calculator blows up. You can't do it. So the slope of this guy is undefined. And in fact, the slope of every vertical line is undefined. Which also kind of makes sense. Like we know that the slope is, again, a rise over a run. And so like maybe going from this point to this point, we rise however much. but we don't get to run at all. And so if we're trying to compare how much is the rise relative to the run, well, there's no run happening. So I can't tell you how many times bigger the rise is than the run. And so the slope of a vertical line is undefined. Yes, 0 on the bottom of a fraction is undefined, automatic. Okay, big conclusions. Who was our reader before? Was it Jeremy? Can you do 3? Okay, so this is pretty much everything I need you to take away from this page. It's about the equations of a vertical line and the slope, and the equation of a horizontal line and the slope. It's all captured right there. Let's do one quick example, and then we'll move on to the other topic for today. We're skipping 4. You can read it later on. We're just going to do 5 and essentially cover what's in 4. 5 says, find the equation of the line that has m equal to 0 and passes through the point 3, 2. M equals 0 and passes through the point 3, 2. Oh, just one quick thing to help you distinguish. Like we know that we've got these two special lines, vertical and horizontal, and one of them has a slope of 0 and one of them has a slope that's undefined. And to figure out which one is which, this is how I think through. What kind of a number would you have on the slope for an uphill line like this? Is that a positive or a negative slope? It's a positive slope. And on a downhill line, what kind of a number? Is a negative slope. And what's the only number that's between all the positive numbers and all the negative numbers? Yeah, so the line that's between them is the horizontal, and the number that lives between the positives and negatives in either one is what number? Is 0. And so, like, if I know the horizontal line is in between and I know 0 is in between, then it sure stands to reason that horizontal has a slope of 0. Make sense? So that's how I remember which one has a slope of 0. Okay, so part number 5 again. So we got something which has a slope of 0 and passes through the point 3, 2. So here's my thought process. Slope of 0, which one of our two special lines is that, vertical or horizontal? Slope of 0 is horizontal. This is just one of our big conclusions now. We've got to have this tool in order to answer that question. So I translate that to say, okay, I know that I've got a horizontal line. And if you have a horizontal or vertical, then the equation of that line is special. It's either y equals a number or x equals a number. Which one is it for the horizontal line? It's a y equals. And this is just, again, something on the previous page. It's part of the big conclusion. As you're making your reference sheet for our upcoming quest, I would recommend copying word for word that stuff on the big conclusion. But we know from that big conclusion that every horizontal line has the equation y equals some number. And the last piece of this puzzle is to just figure out, well, what is y equal to at the only point that we're given? 3, 2 is 2. So if y has to equal some number, and the only y I'm given there is the number 2, then y equals 2 must be the answer to this question. 3 is irrelevant. So with a little bit of practice, this process becomes like a 10-second process. It's not a long problem, but there are a lot of ways to get it wrong. So you got to make sure you become comfortable with the process. Don't worry about like memorizing a lot of stuff, and make sure you can follow that process. Yeah. You don't want to have like a 0x. So it's totally fine to do what Ben is suggesting here. I think you're talking about coming back to this y equals mx plus b. Totally fine. And you know that the slope is 0 in this case, and so so you can say a 0 right there. And you can do a little bit of work, like you can plug the point 3, 2, and you can treat this like the problems that we solved in the previous class. But the problem is that if I told you that the slope was undefined, there's no way for us to use that y equals mx plus b formula. You can't put something undefined into that y equals mx plus b formula. And so instead of saying, if it's horizontal, you can use the formula, and if it's vertical, you can't, I just decide, how about we just treat these guys both as being special? But certainly you could do what you're suggesting for horizontal. Okay, so that's that one. Number 6. The three lines graphed at right appear to be parallel. You guys know the word parallel, right? What does it mean? They'll never touch each other, right? Lines will never touch. Let's look at their equations. So the equations are given: y equals 2x plus 4, y equals 2x minus 1, and y equals 2x minus 8. What number is the same in all three of those equations? Is the slope. It's all 2. And so it sure feels to me like if lines are going to be parallel, they got to have the same slope. That's what I'm getting from this picture. And so that's what it says here in number 7. Two lines are parallel if their slopes are equal. If M1 is equal to M2, or M1 and M2 are the slopes of the lines. All right? So that's the conclusion, and you're going to use that in a minute. But that's all I got to take away from that picture. Parallel lines, same slope. Life is a little bit more complicated when you have perpendicular lines. So first, what does it mean for two lines to be perpendicular? Intersect at 90-degree angles. Yeah? And what's another word for a 90-degree angle? Starts with R, a right angle, right? They intersect at right angles. Good, and so that's what's going on here in this picture. And then I'll give you some points. I say the point 0, 4, and 3, 2 lie on this L1, and those are the two red dots up on the board. And then 0, negative 2, and 2, 1 lie on the L2. So I want these two tables right here to find the slope of L1. Can these two tables find the slope of L2? And then we're going to compare our numbers. Go ahead. All right, so you guys just did some calculating. You got negative 2/3 and you got positive 3/2. So write down the other one because you only calculated one. And then there's this observation that you're supposed to make. Those slopes are not the same, right? So it's not the same. It's not this parallel business we saw up above. Savannah, what did you notice about those two numbers? Opposite reciprocals. It's a mouthful, but it exactly captures the relationship we want here. If two lines are perpendicular, then their slopes are opposite reciprocals. Now that's two words, and you got to understand both. What does opposite mean? One positive, one negative. Opposite signs. And it kind of makes sense, right? Because if I just give you like some random line like this one here, and I say perpendicular, okay, so now we're talking like something like that, would you agree that one of these lines is going uphill, and one of them is going downhill? And so there's got to be a positive slope and a negative slope. You can't have two perpendicular lines, both of which are going uphill, right? And so the opposite makes sense. And then the reciprocal is a fancy math way of saying what? Flip the fraction. Okay, it shouldn't be clear why flipping the fraction gives you perpendicular, but it turns out it does. And so that's what's written down here, is that the slopes are opposite reciprocal. Okay, so activities start on the next page. The goal, as usual, is to finish all the activities. Then if you have time, you're going to work on the even more activities. And at some point, I'm going to cut you guys off, and we're going to do this unusual thing where we tackle the demo from next class. All right? Let's see how far you can get until then. Okay, so we'll start with Savannah for the summary. Thank you. Ben, number 1. Okay, so let's make sure we're clear on what that percentage means. So you have a certain number of people sadly dying each year from car accidents. And of those deaths, a certain percentage are related to alcohol. And those are the numbers that we were looking at, okay? It's what percentage of all the folks who passed away in car accidents, and what percentage of those accidents was alcohol a factor. And so, we have that one data point, 57%. How about 1985? Was it higher or lower, that percentage? It was lower, right? Went from 57 down to 51, and we can see it appears to be going lower every few years, is what the table says. But we really can't say much more than it seems to be going down by looking at the table. And so instead of just looking at the table, it turns out if you put this table information into a graph, you can immediately see maybe a lot more than you could by just looking at the numbers in the table. So to display the data in the table, we use something called a scatter plot. That's what this picture is. We're going to let P represent the percentage of driving fatalities that were alcohol related. That's the vertical axis, so it's like the Y. at T years since 1980, which is the horizontal axis. So when I say since 1980, that means T equals 0 is when we're starting the clock in 1980. So T equals 1 is 1981. T equals 2 is 1982. Okay. All right. So here is the scatter plot. And I can see more than just, yes, it appears to be a downward trend, but I can kind of get a sense of like how steep that line is, right? Like how downward is it, which I couldn't really tell just by looking at numbers in the table. So first thing, let's see if we can grab the coordinates of some of these points. So point A, what are the coordinates reading off from the graph? Looks like 850. How about point B? 19 and 37. Can I tell by looking at the picture that it's 1937? You got to look at the table, right? The table is what picture came from. So we can look at the table and let's verify, is 8 comma 50, is that one of the points in the table? Let's see, 8 would be 1988, right? And so 850 is exactly that row right there. And then the row that we're talking about here, or that point we're talking about, it looks like it's about 19, which is 1999. So I guess it's that guy right there. So 19 comma 37. So we use the table together with the graph to fill in these points. That's 19 and 37. Okay. Let's see. So we did A. Part B talks about trends. And would you say that this is an increasing, decreasing, or neither trend? Looks like it's a decreasing trend, right? Like as time passes, the percentage seems to be decreasing. So a decreasing trend. Super. Part C, on the scatter plot, I want you to sketch a line that you think fits the data the best. Use a straight edge. There's those yellow folders, so somebody can grab that. If you have like a phone or something, like use something to be a straight edge, and you're going to draw what you think is the line that's as close as possible to all of those points. Now, this is a very imprecise thing I'm asking you to do in math class, which is typically a very precise place, but you are just drawing the line you think fits the data the best. I don't want to say there's no like wrong answer to this, because there actually is a single right answer, but there's a whole wide range of acceptable answers for what I'm asking you to do right now. Right? So we are all going to have drawn different lines. I'll draw mine right now. Okay, so there's my line of best fit. It looks different than yours, right? We all drew a different line. So so that's delete. Good. All right, so so there's a line that we think fits the data the best. Now we'll go to the next page, and we'll come up here, Lucas, for number 4. Good, and it says there the data appear to be roughly linear. I just want to show you what it might look like to say it's not roughly linear. So suppose that this is what your data look like. Would you say that that is kind of like a straight line that that data is following? No, it's kind of all over the place, right? Whereas the data that we had was kind of clumped together. I mean, it's not perfect, it's not on the line, but they're all pretty close. And we don't have this kind of all over the place. So that's what we mean when we say that the data looks roughly linear, right? Okay, so part A, I'll come up here to Cody. Okay, Marcy. Thank you, Irene. Okay, so first thing we need to do is translate 1993 into a t value. Remember, 1980 was t equals 0. So 1993 is what t value? 13. Everybody good with that? So we're going to look at the picture at the top of this page, which isn't your line. It's a line that I got from a computer program. But we're going to use that line. So we're going to go to t equals 13. So 13 is right around there. We're going to go up here. Notice that there's no data point there, right? Data points on the left and right, but there's nothing at t equals 13. And we're going to use the line. And from here, how do I estimate the percentage for that moment in time? We're going to go to the y-axis. So from there, you go straight to the left. Ballpark, 42, 43, either of those is good. Again, there's a range of answers that are full credit answers to these kinds of questions. Okay, so then we'll say P looks like it's right around 42, maybe 43. Everybody all right with that? And we just got information that we weren't given. That point is not in the table, right? It didn't say anything in the table about 1993. And we're making our best guess using that line, and we come up with about 42, 43%. In reality, the answer is definitely not going to be exactly 42 or exactly 43, but we can estimate it and have a, a fairly reasonable amount of confidence that our estimate is pretty close. Okay, so let's take a look at part C here. We're going, Irene, did you read? You did. Alex? C. Let's pause right there. Okay, our goal for the rest of this class is to find the equation of that line right there. Find the equation of that line. Now, this is a problem that we have solved many times. We have found many equations of lines this semester. And in order to find the equation of a line, if you are given 2 points, we have a process that we have followed already. In fact, we followed that process today. So the first goal is to just pick off 2 points from that line. Now, I'm not picking 2 data points. Are any of those data points actually on the line? No, none of them are. There's one that I guess kind of looks close, like this one over here looks like it's close, but you can tell it's not perfect, right? Like that point is a little bit below the line. So we're kind of ignoring the data points, which is a weird thing to do because we know the data is accurate, but we're ignoring it completely, and we're going to use our line, and we're going to try to pick 2 points that are on this line that have like nice coordinates. So can you find any point on that diagonal line that is also on the underlying grid? Understand what I'm saying? 8, which one? 8 and, oh, sorry, 8. Yeah, maybe there. So what are you saying that is, Irene? 8 and, yeah, so what do you guys think? 850? Would you say it's more or less than 50? It's a little less. So if you said 849, I got no problems with that, okay? How about this point right here? 1640, yeah? Like, again, it's not going to be perfect, but it looks really close to being right on the grid. So this is what I mean by saying pick points that are on the line, but also easy to read on the grid, 1640. Now, I think Irene's point is a fine one to pick. The one that we're going to pick is this guy right over here. What are the coordinates of that one? The x is easy, right? That's 20. And then the y, we're going to estimate 35. I'm happy with that, but I'm not any happier with 35 than I am with Irene's 49. So again, there's a wide range of answers here. Just try to pick points that you think are going to be easy to estimate those coordinates. Okay, and so down here in C, I've actually already written out the points that I want us to use, the 16, 40 and the 20, 35. Notice that it's T and P, not X and Y. Okay, part D says using the points we picked, we're going to find the equation of that regression line. First, we got to find the slope. This is step 1. So let's give it a shot. We'll include units and then we'll interpret, but let's first fill in. Notice that I've got a couple of things already written out. First, M is our letter for slope. Change in Y over change in X is one of our definitions for how we calculate the slope, but X and Y are not relevant in this problem. It's not those letters. What is it? It's T and P in some order, and you got to put them in the right order. So how do you know what the right order is? Well, I know x is first and y is second, so I guess x goes with t and y goes with p. So which letter goes on top now instead of y is the p. Change in p over change in t. And this is important because you guys have a lot of experience with change in y over change in x, but I'm going to push you to use not x and y in problems where x and y isn't really a natural choice. And so we need to be able to translate. It's like a mental hurdle we got to get past. Translate into any letters that I give. Okay, so we're going to subtract. I will subtract in this order right here. So upstairs, what are we putting? Let me do the. I'll write it out. So 40 minus 35 is what I'm putting. You might have it the other way. Downstairs, what do I have to put? 16 minus 20. Everybody good with that? Again, totally all right if you have both of those swapped. So upstairs for me, it's a 5, and downstairs it's a -4. So is this fraction positive or negative when all is said and done? Negative. So I've got -5/4. And it says here, right, the final answer is a decimal, so let's do that. So I guess that's -1.25. Okay, and I want to interpret that number, that -1.25. It means something in the context of these drunk driving fatalities. In order to know what it means, I strongly encourage you to include the units in the beginning. So when we did 40 minus 35, that was 40 what? Was it 40 years? That was the percentage, right? So upstairs was the percent of fatalities due to alcohol. And downstairs, 16 and 20 were both what? Years. So then the final units for this -1.25 must be percent per year. Yeah? Can anybody come up with a sentence that includes that -1.25 and, you know, something about drunk driving here? Can you say it louder so everyone can hear?
Per year, the fatality rate drops.
What do you guys think? Bingo, that's perfect. Every year is a good phrase to get in there. Per year would be another good phrase to get in there, but you got to get the fact that it's every year something is happening. Alex did something clever. He used the word dropped, and he did not use the number -1.25. What did he do? What number did Alex say in his sentence? Say it again. Say the sentence again.
Here, drunk driving drops by 1.5%.
Right, Alex didn't use -1.25. What did he use? He used dropped, and he changed that -1.25 to positive 1.25, right? That's perfect. Good, so we'll write that sentence in here. Every year, the percent drops by 1.25%. Which one? The percent and percent? Yeah, I wrote that and I was like, oh, maybe nobody's going to call me out on that, but thanks for that. Yeah. So it is kind of redundant. If the percent is, just having the word is good enough. Okay, so we're going to do step 2 here, which says find the equation of the line. We just calculated the slope of the line, -1.25. And we'll find the equation, and we're going to use T and P. Again, this is me trying to stretch you. Let's begin with our standard y equals mx plus b, but this is the last time that x and y will make an appearance in this problem. Instead of y, what letter are we using? It's P. Just make sure you're clear. Don't guess. If you guess, half the time you're going to get it wrong. So y is P. M times what is x? T, and then plus b. That is the new version that we're using for this problem. Okay, we did all the work to find the slope. Slope is -1.25, so P equals -1.25 T plus B. And then we plug in the points. Now we have 2 points given to us, so which one should we use? First one, sure. second one, sure, right, doesn't matter. You can pick either one. Okay, so Irene says the first point, so let's use the first point. It was 16 and 40. So the P becomes which letter? 40, or which number I should say. So 40 equals negative 1.25 times T becomes 16, and then plus the B. Everybody okay with where that equation came from? All right, negative 1.25 times 16. I think it's negative 20. Am I right? So we solve for B by doing what? Add that 20. So B equals 60. Great. And so then our final equation, P equals negative 1.25 T plus 60. Questions on the process? So there's not a lot new, at least in this procedure, right? Because finding the equation of a line given 2 points is something you have done many times now. Today a little bit, last class some more, right? So really the new thing is like drawing that line of best fit and then grabbing 2 points. And I'm going to be a real stickler when it comes to like this kind of a question on the upcoming quest. You're supposed to pick 2 points that are on the line. And we picked, you know, these 2 points, purple and blue, right? What did we not pick? The points that were given. Do not pick the points that are given. And what happens, and this happens unfortunately every semester, but somebody will just say, okay, I'm going to pick this point, I'm going to pick this point. And that's great, except you're ignoring all of the other points, right? We're trying to find the line that's as close as possible to all of the points. And if you just grab 2 of them, then you're giving all of the weight to those 2 and you're completely disregarding the rest. And by drawing our line of best fit, that was our way of capturing all of the points. So you got to be clear, you're using points on the line, not data points. Okay, so it turns out that this is the equation of the line that's graphed. How do I know it? Because the piece of software told me that was the equation. So we can compare our answer to the right answer. Like this is the right answer. Our answer was what, negative 1.25 plus, was it 60? Okay, how did we do? Was our slope pretty close? Yeah, our slope was quite close. How about the y-intercept? Quite close. Again, we were estimating. We estimated with our line. We estimated points. Of course, it's not going to be perfect. How do you get it to be perfect? Take a statistics class. It'll be perfect. Outliers. Fancy. Yes. Yeah, it's that. Yeah, it's that. It's the P equals negative 1.25 T plus 60. That's the regression equation. Okay, so I have 8 seconds. So here's the last thing I'll say in the 8 seconds. I'm not quite finished here. You know what? Let's call it a day. We'll finish this on Monday, and then we'll do the activities, and then try to finish the next class too. Have a great weekend. We'll see you guys Monday morning.